Hello again, friends. This is Dana Paul. What I'd like to do in the video today is to describe the process that I use to go from the idea to the actual finished design in the tamper handle. Now, I've met with a barista and established the handle size that's necessary to be comfortable for this tamper, and we've talked loosely about a design, but the rest of it has been left up to me. I have an idea that I've been kicking around for a month or two, and I think today I'm going to get started on cutting the wood and putting the tamper together. It's nice to have ideas because that's what makes me get out of bed and turn the shop lights on each day. I'm lucky I have a place that I can escape from the unfinished projects that are everywhere in the shop, to work on my drawings and to work out on paper the cuts that I'll be doing on the pieces of wood before I put them in the machines and start the cuts. So I'd like to just follow that process in this video. I'll try not to leave things out, and since I'm excited to get this tamper finished, I think we'll be able to work through it in about maybe 1 or 2 10-minute videos from start to finish. So what I'd like to do now is focus on the drawing on the clipboard and talk about the processes that will be necessary to make this design in the tamper. The idea for this project is a pretty basic curly cherry or figured cherry body for the handle, with the addition of some rosewood blocks added up in the top of the handle in the form of a stitched ring. Now, this is a ring that I'll cut off from a billet that I made of the cherry and the rosewood. For the bottom of the handle, the idea is to have a rosewood border bordering some cherry finger joints that alternately face down and up and down and up as you rotate the handle in 90-degree increments. The handle needs to be 76 millimeters to fit the hand of the barista that the project is for. So the pieces of wood that make up the handle from top to bottom have to be chosen and machined in such a way that when the project is finished, the length of all these combined elements equals 76 millimeters, within about a half a millimeter. Some of the joinery considerations that have to be taken into account have to do with the gain and the loss of length in the various pieces that are assembled. For example, anytime that we cut a finger or a tenon from a piece of stock, in order to create that finger, we have to remove some stock from the area beside the finger. This causes loss in the length of the piece of stock that we have to take into account when we cut the stock originally. In the bottom of the handle, when we create this finger that will point up into the top of the handle, we'll lose some length on either side of that finger when we remove this wood so that that finger exists. So we have to take these two instances of lost length into account when we cut the pieces to assemble into the handle. Obviously, when we introduce the rosewood border back into the handle, we're going to gain the length of the width of this border. So these three losses, the two losses and the gain, have to be taken into account so that we don't upset the important dimension from top to bottom of this handle. At the top of the handle, the concern is that when we slice the handle to insert this stitched ring, the saw, when it cuts through the handle, removes a narrow slice of wood. So that's a loss in our overall length. Then when we insert the ring into the top of the handle, we gain the height of the ring. So what we need to do at the top of the handle is just to make sure that the amount of wood that we remove with the saw equals the amount of wood that we put back in with the height of this stitched ring. That's very easy to do. Another consideration that we might want to think about is the alignment of our decoration with the natural grain of the piece of wood that we've chosen for the body of the handle. You probably know that a given stick of wood, I'm looking at a stick of wood, I'm looking at the end grain right here. If we look at the sides of the stick of wood, we have a flat grain or a flat face and a radial face. And these two adjacent sides of the piece of wood exhibit completely different grain qualities or grain appearance. If we machine this cube of wood into a sphere, what we'll observe is that on the flat sawn side, there will be a series of radiating circles that exist because the cut cuts through successive radial grains and reveals a circle as it works its way in. If we rotate the handle 90 degrees or the sphere 90 degrees and look at the radial face, we'll see a series of vertical lines that result from the longitudinal grain of the wood. Now these are natural characteristics of the wood that we've chosen. If we're fortunate enough to have a piece of wood that's quarter sawn that will let us orient the radial faces and the flat faces exactly 90 degrees to each other and 180 degrees opposite each other, then we can align the features of our decoration with the natural features of the wood. And we could, for example, align the fingers that point downward to line up with the flat face pattern that'll be at the bottom of the handle, and the fingers that point upward can align with the vertical grain or the radial face. These are things that we might want to take into account when we select the wood for the project. There's one more issue that I'd like to talk about before we go down to the shop. To preserve the alignment of the grain characters of the piece of wood, we have to devise a system that will let us cut through the piece of wood and then join the piece of wood back together with the vertical lines or the circles from the flat face as they were before it was cut. We already talked about making sure that the saw kerf and the ring are exactly the same height so that we don't upset the relationship of these flat face circles from each other. But we need a system that will let us align them from left to right so that we don't shift the top and the bottom left or right and cause misalignment between these vertical grains or misalignment between the circles of this grain feature that is revealed on the flat faces. The way that I do that is to put a dowel in the center of the top of the handle. I bore a hole into the bottom half, I bore a hole into the top half above the ring, and I bore a hole through the middle of the stitched ring itself. Now this dowel is sized very closely to the hole that I bore, so that when these three pieces slide onto the dowel, they're a tight sliding fit and they can't move left or right relative to each other. All I have to do then is rotate them on the dowel relative to each other so that these lines line back up exactly when I put the glue around the dowel and slide the pieces on. There's about 5 or 10 seconds of stress in this method, but usually if you move quickly you can get these grain lines aligned sufficiently so that when the glue sets you don't look at them and say, "Don't tell me I didn't get them lined up again." It takes a little bit of practice, but that's the way that I go about it. I think that about covers it for the discussion of the project on the worksheet. There will be a lot of discussion of these same ideas when we're looking at the pieces down in the shop, when we're setting them up in the machines for the cuts that we have to make. That will probably be in the next video.